All right, so welcome back. We are back, CSE 101, Intro to Programming. We will continue our discussion today on methods. One thing, though, I did want to go over because, so I have a question. No, okay, just accidentally put your hand up, I guess. Okay. One thing I did want to go over was, so I went ahead and graded all the quizzes. The in-lecture and those that were excused from lecture for the after-lecture quiz. And what I noticed was there was a disconnect between Microsoft Teams and the Microsoft Forms site. So what I want to do is, I really feel strongly that information is key, and if they give you all the facts that you guys can understand what happened. Okay, so what I'll do, I'm going to share my screen so you can actually see what I'm seeing when I do this. Okay, and I'll just share my straight desktop because I'll be clicking through a few different things. Okay, so let's see here. Okay, so let's go straight to here first. Okay, so don't necessarily want to show you the grades though. That's the problem. Okay. Basically, if I click on my assignments tab here, I can see all the assignments that I've given or those that are upcoming. So here, this one, for example, is due in a few days, right? So go ahead and if you haven't already done that, 30 of you have already turned it in. Great. Okay. The rest of you go ahead and get going. Yeah, I think that's Sunday night, if I'm not mistaken. All right. If I look back at these other assignments here, okay, so if I were to click on this, I would see everybody's grades, okay. The thing was when I created this quiz, okay, so this is what you saw, right? Okay, you saw these questions here, some of you. When I put that quiz into Teams, it created a version of the form, okay, that then connected to the Teams assignment, Now, the original form is this one here. So notice there's a difference. This right here, this is the form that's directly connected to the Teams assignment. This is the general form. All right, this is what I expected you guys to take. And for those of you who clicked on the link that I posted, this is the one that you saw. For those of you that clicked on the assignment in Teams and got redirected to Forms, this one is the one. This one is the one that you saw. Okay. Now, I would expect that shouldn't be a big problem, except for some of you, when you clicked on this one, it was an old version of this this quiz, and so where was it? Like, so if I look at the questions here. So it included this whole, use to create a method that takes two integer parameters, which I made a change to that to make it instead. Now this is the one that those of you who clicked on the direct link instead of the Teams assignment, you saw this where it was write a code segment. So I can see now that there was some confusion with that. So hopefully going forward, we can fix this, because that was not a good thing that was not a good thing for you guys to have a confusing quiz like that. But you know what? We're all learning, right? We're all learning how to use this tool and how to make it work for us. And I'm really glad that we discovered this before the upcoming midterm exam, because your midterm exam will be a Microsoft Forms thing like this. So I'm glad we got that all organized and figured out. All right. So if there are any other questions, also, what that means is if you clicked on the link form, like not the one that's connected to Teams, if you clicked on the link, so if I, again, sorry, let me go ahead and share my screen again so you can see this. If you, so in this if you were in here, okay, right, and if you clicked Did I not post the link? Did I put it in here? Where did I post that link? Huh. Did I put it under assignments? I'm sorry, I can't seem to find where I posted. I remember posting a URL so that you guys could have access to the link, right? Is it in here? No, I don't want that. Okay, I don't seem to see it, so I don't see where I put that link. Maybe it got deleted. Now, I'm very sorry. I don't seem to see it. Oh, here it is. Oh, okay. So it's up above this meeting thing. Oh, okay. So if you clicked this, then what happened was you got brought to that main form, and rather than this assignment form. Okay. And what that means is that this form was not directly linked to the team. And so what you would see is you would get a grade over here. You'd get a grade over here. You would be able to see your grade on this one. Okay. But you wouldn't see that grade in Teams. Okay. So if you took this quiz, but don't worry, I have all the grades saved in a Google sheet somewhere else. So you have a grade. If you took the quiz, and if you see a grade over here, you know, the average score on this version, for example, was 41.7. If you see a grade in there, it is in my Google Sheets. Okay, so I have your grade saved. All right, so just because you don't see one over here in Teams, just because you don't see a grade over here in your Teams app, don't worry about that. You have a grade on that quiz if it showed up. Okay, all right. So I hope that's clear. If it's not, please make sure you ask questions, and I want to make sure that you understand what happened and how we're handling it going forward. Okay, I've spent enough time on that, I think. So I want to finish off methods today so that you guys can have all the tools that you need. All right. Okay, so we talked about methods last week. Oh, first and foremost, my quote of the day. So Mr. Gordon Moore, if you know Moore's law, that's where that comes from. It has to do with microchip design. With engineering, I view this year's failure as next year's opportunity to try again. Failures are not something to be avoided. You want to have them happen as quickly as you can so you can make progress rapidly. So I love quotes like this because it just reminds me that just because we don't succeed the first time does not mean that that's necessarily a bad thing. Failures can help us if we learn from them. Like we don't try to do everything to avoid failure. I was just talking to a friend of mine last night. When we first moved to Turkey about 7 years ago, I met a man that he said that the key to learning Turkish was to make 10,000 mistakes. And he said some people try really hard to avoid mistakes at all costs. They never say anything unless they absolutely are certain they're saying it right. They never write anything unless they're 100% certain that it's correct. So, and it takes them so long to learn the language. Right? Some people say, you know what? I'm going to make mistakes. I'm going to say things wrong. I'm going to write things wrong, incorrectly. And if I can learn from those mistakes, I will learn the language faster. And I hope that I've had that attitude, and I hope that I've done well at learning Turkish. So we'll see. Maybe if some of you guys get to speak to me in Turkish whenever this whole pandemic stuff is over, maybe we can see how well my progress has been going. But the key is as far as understanding that failures is not a bad thing. My first job in engineering was as a software tester. I wasn't actually a software developer, in my first experience working, and it was really interesting because my job was not to prove that the software worked. The job of a tester is not to prove that software works. The job of a tester is to find places where it's not, right? Because we can never be absolutely 100% sure that a piece of software works. What we can do is we can find places where it's not working and fix them, right? And so what we want is we want to find problems early so that we can fix them early so that the customer never sees them, all right? So if you guys learn anything, I want you to learn that it is okay to fail as long as you learn from your failure. It is okay to make mistakes as long as you fix them. Okay, don't be so afraid of making mistakes that you just avoid doing anything at all. Okay, all right. Enough philosophizing. Let's talk about methods. So we ended last week, we were talking about, I'm going to go up a slide actually, because we ended last week with this whole difference between a void method and a method that returns a value. So remember, in the void method, the one that does not return a value, what we did was we displayed something to the screen, right? So we passed it a value, a grade. We displayed the letter grade for that point value. And then the method ended. We didn't return anything, right? Then the same thing, we did something similar with this test return grade method, where what we did was we passed it a score. We figured out what grade that should be based on the score, and we returned that value, that character value. Right? It didn't display anything. This method didn't display anything. It just returned a value. Okay, and then the main method, the calling method, was the one that displayed something there. Okay, so and what I showed you guys was both of these classes, both of these main methods, did the exact same thing in terms of I gave it a score, I displayed a grade. All right. Both of the main methods did the same thing. That doesn't mean that the stuff inside of them were the same, because one of them had a method that it called to display something else. One of them had a method that it called to get a value. Okay. One thing I want to point out here, I think I still have it up. I can't share it right now because I'm just on the PowerPoint. So one of the things that I showed with this test return grade method was we passed it a double and we returned a character. We returned a char or a car variable value. Some of you, I think, based on some questions that I've been getting, are a little bit confused because some of you have thought that whatever we passed into the method, we had to return that same type of value. And I think what made you think that was this guy right here, where we passed into integer variables and we got an integer back. Okay, that's not always the case. So for example, here in this return grade method, we pass it a double, but we get a character, right? And here in the test void method, we pass it a double and we get nothing. We get nothing back, nothing gets returned. Okay, so the method does not have to return the same type as the variables that it gets. In fact, what we'll talk about today when we're moving on into this parameters passing is we can pass multiple types of parameters to a method. Okay, now order will matter, and we'll see that in just a moment. Okay, but let's just get into it. So let's say that we wanted to print the same message on multiple lines. So let's say we wanted to print the welcome to Java message 5 times. Okay, and we wanted to print the computer science method, the string 15 times on 15 different lines. Okay, now we could do that like this, where we pass it a string for a message and integer values, and then we loop through from 0 up to n-1. every time through printing the message on the line. So this will print welcome to Java 5 times. Welcome to Java, next line. Welcome to Java, next line. Welcome to Java, and so forth. Same thing with this one. It'll print computer science, computer science, computer science, computer science. Okay. Now, question for you guys to answer. Okay, it's a bit early, I know, but let's wake up. What happens with this last one? What's going to happen with this last one? Right. All of you guys seem to be saying so. Error, yes, it will be an error, and whoever the first person, Recep, or is it Samet? I don't know. Some of you guys that have the two names like that, I know sometimes you go by your middle name. So first one there with the compiler error, absolutely. The reason why this will be a compiler error is because the order is not correct, and it's not just the order is not correct, the type is not correct. Okay, so for example, if we go back, let's take a look at this one. If I had put I then J, or if I had put J then I, this would not generate any kind of error. Okay, and the reason why is because the types are the same. So as long as I put an integer here and an integer here, that's all that matters. Okay, but here the problem is the first parameter has to be a string, and the second parameter has to be an int. So the fact that I put an int first and a string second is a problem. So what the compiler will try to do is it will try to put this into a string variable, and it's going to say, hey, that's not a string type. I can't put that into a string variable. Okay. So even if we did that, so if let's say we said, okay, well, let's do this then. It will still give me a compiler error, because even though now this will be a string, even though this will be a string, this will not be an int. So it'll say, hey, you're trying to put a string into an integer. That you can't do that. Okay. And we can't just do this, because then we're just going to get a whole lot of craziness, right? Because now you have this weird stuff going on, right? So we can't do that. So the thing I'm trying to get at is that right now in current computing, as far as Java is concerned, right, we don't have smart enough computers that could look at this and say, oh, the programmer just put the parameters in there opposite, right? So I should switch them up. Like a compiler won't be able to do that, right? Maybe in the future with advancements in AI, artificial intelligence, we can have some of that, but right now we are unable to have that. Okay. All right. So make sure you get the order correct. Okay. This is not generally a problem that we experience. Usually what will happen is the first parameter will need to be an int, and the second parameter will need to be like a double or something like that. And what will happen is we'll do those in reverse. Okay, because since they're both numeric types, us as programmers sometimes we think, oh, they're both numeric types. We can put them in whatever order, but that's going to give us problems. Okay, all right. All right, so one thing to talk about is when we pass values to a method, we do what's called pass by value. All right, what that means is it is not the same thing that we are passing, but rather a copy of the value that we are passing. So let's take a look at this, right? So we'll take a look at this in the example. We'll do that here in the later time in this class. All right. So what happens is we have a main method, right? And what we do in this example is we try to swap two values. Okay? So what this program does is it tries to do a typical swapping algorithm where two values, num1 and num2, we try to swap them. Okay? The problem is that when we come back to the main program, the numbers aren't swapped. And the reason why is because the values are copied. Okay. So here, when we pass num1 and num2 to our swap method, n1 and n2, 1 gets copied into n1, 2 gets copied into n2. We end up swapping those, and we'll see that happen. I'll show it to you live. And then when we return to the main method, the values are still the same order that they were before, and it's because we swapped the copies and not the originals. Okay. For anybody who may have previous programming experience in C, there's a way that C allows us to be able to do this. Okay. C allows us to be able to swap things by doing what's called a pass by pointer. Java does not allow that. Java does not have that capability right now, but there are other ways that we can try to do something similar, and we'll talk about that starting next week when we get into arrays. Okay. All right. Modulation, right? So the methods is we can reuse them to be able to do the same thing using different inputs. Okay. We'll skip over that one. I do want to talk about the idea of overloading. Okay, we'll talk about this way more in detail next semester in CSE 102. But for now, I do want you to know the idea of that you can have the same method with the same. You can have, sorry, not the same method. You can have a method with the same name that takes different parameters, and it could be a different method. Okay. So as an example, the max method here. So if we created a second max method with 2 double parameters, then we can pass it 2 double numbers and be able to do a similar thing. See, the old method max with 2 integer parameters figured out which of the integers was greater and returned the integer that was greater, right? But we couldn't pass 2 doubles, right? If we passed 2 doubles, if we passed or even 1 double to it, then we would get an error, right? We would get a compiler error because it would say you cannot put a double number into an integer variable. So now we have a way that we can do this by using doubles, and it's 2 distinct methods because the signatures are different. You guys remember that what we call a method signature, that this is your method signature, right? And because it's different, 2 doubles, then that's considered to be 2 different methods. Okay? And it will not give you a compiler error. If I tried to put in 2 methods with the same name and the same signature, then it would give me a compiler error because it would say, hey, you can't do that. You can't have 2 methods with the same signature, but you can have 2 methods with different signatures, even if they have the same name. Okay. So the reason why I want to go into this is because a problem that can come up is what's called ambiguous invocation. So when a compiler tries to what is it? When you're calling a method and there's 2 or more possible matches, 2 or more possible methods that could be called, because remember, this method and the other max method are not the same. Okay, they're not the same method. So when I say call max 3, 2, well, I could call this one, but I could also call the other one. So it tries to figure out which one to use, but it will try to determine the most specific match, and if it can't, then that's a problem, and it'll give us a compiler error. So let's look at an example of how that might work. Okay. All right. This would be an ambiguous invocation. Now, we have one max that says, give me an int and a double. Okay. We have one max that says, give me a double and an int. Okay. What happens if I pass it 1, 2? Well, it's going to first look for one that is int, that looks for 2 ints. Okay, I can't find that. That one doesn't exist because that would be the most correct match. Would be if there was a max method that took 2 integer values, that would be correct. That would be the most correct. Okay, so can't find that one. So then it says, okay, well, I can't find 2 ints. Well, let's see. Can I find one that's an int and something else, or something else and an int? The problem is that now both of these tie for correctness because they both have one int and something else that is good enough. So then it says, well, I can't figure out which one of these to use. And again, this is an example of where a compiler is not smart like you and I, because you and I would look at these two methods and say, well, they do the same thing. They do the same thing. Why does it matter which one you call? But the compiler doesn't know that. The compiler isn't able to abstractly think through that these two do the same thing and send back the correct value. Okay? So be careful about ambiguous invocation. It will result in a compiler error, so it at least tells you, there's a problem and you can fix it. It's not a runtime error or worse yet, a logical error. All right. So I hope that's kind of clear. We'll see an example of that. So we'll go through some examples of that when we get there. All right. Some other things I want you to understand is variables that are within a method only exist inside the method. Okay, so like a local variable. So for example, here, let's see, not that one. Back up here. Yes, here. So result would be a local variable because it's declared inside of the method. Okay, it's only declared inside of the method. It only exists inside of the method. Okay, that means that I cannot access that variable outside. Now I can have another variable with that same name outside, but it's not the same variable. Okay. So the scope is where it can be referenced. So wherever the variable is declared, that's where it can get used. Now we talked about that some with loops as well, that when we declare a variable inside of a loop, it only exists inside of the loop. If we try to use it outside of the loop, our program will tell us, hey, you don't have that variable outside of the loop, right? So, so a good exam or quiz question is when I'll declare a variable inside of a loop. I'll tell you, hey, what's the final value of this outside of the loop, and you're supposed to tell me that there's an error of some kind. Okay, and we'll talk about that because I can almost guarantee that a question like that will show up on this upcoming midterm, and we'll talk about that, what format that will take. So I think, yeah, next week is the last class week before exams for this class. So what we'll do is next week we'll save some time at the end for exam review. Okay, so we'll use the last hour of next week for midterm exam review, so you can ask questions. I'll go over kind of what to expect, and you guys can ask questions. All right. So moving on. Again, so here, this is what I was talking about. The scope of I is only inside of the loop. The scope of J is only inside of the loop after it's declared. Okay, so I can't use J here. I can't use I or J here. I can't use I or J after the loop is over. Okay, that's probably one of those things that is a common error that programmers make, is trying to use a variable's value outside of the loop or the method where it was declared. All right. Okay. All right. One benefit that gives us is that we can declare I for this loop, and then we can declare I for this loop. That's a good benefit for us because what that means is that we don't have to keep renaming like a new iterator for our future loops, especially if we have some, long set of code that involves multiple loops. We don't have to keep doing a new iterator variable. We can just do it here, use it inside the loop. As soon as the loop's over, I is gone, it's not used anywhere. Guess what? We can create I again. All right, we can create I again, use it again, and we can even do that 20, 100 more times if we want to. However, sometimes we may want to say, okay, well, let me use I as a iterator for an outer loop or an outer method, but then we try to do it inside of there as well, and that's a problem. This will not allow us to re-declare I here because it exists already. So make sure you understand. Here, okay, I can do that. I can redeclare and reinitialize I here. Here, I can't do it. I have to, if it's already declared, I cannot redeclare it again in this example, in a nested loop or a nested situation. Okay. All right. Again, here's some examples, some fine with no errors. I declared only exists for the loop. I is declared again. Do you have a question? Right. If it's nested loops, I cannot. If it's nested loops, I cannot declare I twice. So right. So like something like this, I cannot declare X inside of the loop because it already exists outside of the loop. Any variables declared out here also exist in here. Any of the variables declared in here do not exist out here. Okay. So there was a question. Is that it? Okay. All right. So I hope that is clear there. Because the question you were asking too is, what if I do? I think what you were asking was, what if I do like this? So if I do something like this, this would give me a problem. Okay, this would give me a problem because I is declared, I is used. Inside of this loop, we attempt to declare I again. This would give me a problem. This would not be allowed. Okay. This original format, though, is fine because once this loop is over, I is what we call deallocated. Okay, or what you'll learn about next semester, we'll talk about garbage collection in Java, where once this loop is done, I is no longer used. It's gone. Okay, and so here we can declare it again because we don't need it. We didn't need it before, and so now we need the same variable name again, and it's okay here because it's outside of this loop. Okay, I hope that clears things up there. Good question, very good question. Alper, thank you. All right. Now again, if you think of a method as a black box, right, and the inside of here, this is what we see. We see the method header, we see the signature. We don't necessarily always see what's inside of it if we didn't write it, right? So we can send it arguments, we can send it parameters, we get some return value possibly. It may display something, it may return something. It's all depending on what the purpose of the method is. The vast majority of Java methods, like in the different classes, like the math class, the string class, different things like that, the vast majority of them return a value, don't display something. Okay, that's not to say that the methods you create will all do that, but I would say more often than not, we use methods for calculating and returning a value rather than displaying something. Okay. Some benefits. right? We can write a method once and reuse it anywhere. We want a method that adds up the numbers from A to B. We write the method once, we can use it anywhere. Okay. Information hiding, if we don't want our user to have to understand what's going on, right? We can do that. It reduces complexity, meaning that we can have shorter looking code segments that call methods rather than writing this long hundreds of lines of code to do some simple task. Okay, so we get to reduce that complexity and make it cleaner, make it look better. Okay. I will go ahead and have you guys, I would say, look at this generating random characters as a case study of how to do this. Okay. Let's see. So go ahead and take a look at how you could do that, right? Because the math.random method, so just like any other method, random is a method, it returns a value. It returns a random number. Okay. There's some other stuff here. I do want to talk a little bit about this design of how we might want to do something. So let's take this example that they give us is how to print a calendar. And we will take our first break as soon as I'm done kind of going through this. All right, so the idea is we want to enter whatever year it is, enter what month we want to show, and it should print out the calendar for that year. Okay, so this is a big problem. This is in a sense that, and I don't mean big as in like, oh, world changing or anything, but what I mean is anything that's not a single line of code can be broken down into smaller pieces. And we talked about this at the very beginning of the semester about how to break a problem down into smaller pieces. And I'm just now realizing that this is actually a longer discussion than I want to do before the break. And I feel like you guys have been given quite a good chunk of new information for today for the first segment that we're doing. So actually, let's take our break a little bit early. I do want to ask if there's any questions first before I take this break. Are there any questions? Because if not, let's go ahead and take the break so that I can have more, so I'm not coming up against the deadline trying to describe how to break this problem into smaller pieces. Okay, so let's go ahead and take the break now. We will come back at 10:25 and we will continue our discussion on the design diagram then. Again, I'll be here if you have any questions during the break, feel free to ask. And yeah, other than that, go get some coffee, tea, whatever, and I'll see you in 10 minutes.